Hi, Assalamualaikum and good day. Today we are going to learn the first chapter that is on functions. These are the objectives of today's lesson. By the end of this session, you should be able to identify relations and functions, determine the domain and range of functions, and serve the basic operations on functions. Following is the outline of today's session. We will start with the introduction on relations and functions, followed by finding the domain and range for different types of functions, and finally serve the operation on functions. Refer to the following diagram. Given two sets denoted by x and y. If each element from set X is paired to element in set Y, then there is a relation between X and Y. Set X is said to be the domain and set Y is the codomain. There are various types of relation between X and Y. For the first diagram, the relation is known as one-to-one. Second diagram, many-to-one. Third diagram, one-to-many, and the last diagram, many-to-many. Basically, a function refers to a relation if each element in the domain set is mapped to only one element in the codomain set. Therefore, the relation of one-to-one and many-to-one are called as functions. Take note that the relation of one-to-many or many-to-many is not a function because there exists at least one element in the domain set which is mapped to more than one element in the codomain set. It is helpful to think of a function as a machine. If X is the domain of the function, when entered the machine, it is accepted as an input and the machine produces an output according to the rule of the function. Generally, domain is the set of all possible input and the range is the set of all possible output. The function that map from x to y is denoted by fx equal to y, in which x is the independent variable and y equal to fx is the dependent variable. Refer to example 1. Given that fx equal to 3x minus 2, determine the value of the following functions. By substituting the x with -3, 0, 4, and 10 respectively, you will obtain f-3 equal to -11, f0 equal to -2, f4 equal to 10, and f10 equal to 28. Next, to find the value of x so that fx equal to 13, you need to solve 3x minus 2 equal to 13. Simplify the equation, you will obtain x equal to 5. As mentioned earlier, domain of a function is the set of all possible input, while the range of a function is the set of all possible output. Consider a function fx equal to x minus 1. From the diagram, the domain of the function is referred to the set of 0, 1, 2, and the range is referred to the set of -1, 0, 1. In the following section, we are going to discuss on how to find the domain and range of the following functions. But before we go further, make sure you know the basic graph of the following functions. You may also use the following website to plot the graph of any function. For fx equal to x, the graph of this function refers to a straight line from the top right to the bottom left. As fx is defined for all x values and all y values, the domain and the range of fx are both equal to negative infinity to infinity, which can be written as negative infinity, comma, infinity, both with open brackets. Next, for fx equal to x squared, the graph of this function refers to a parabola or a small curve above the x-axis. As fx is defined for all x values, the domain of fx is equal to negative infinity to positive infinity. However, the fx is only defined for y positive. Therefore, the range of fx is equal to y greater or equal to 0, which can be written as 0 with the close bracket, comma, infinity with the open bracket. For fx equal to square root x, the graph of this function refers to half parabola from origin along the x-axis. As fx is defined for all x positive and y positive, the domain and the range of fx are both equal to 0 to positive infinity. Now, refer to example 2. You need to find domain and range for the following polynomial functions, in which a here is linear, b and c are quadratic, and d is cubic function. Basically, there are two methods that can be used here. First is known as graphing method, and second is the algebraic method. When using the graphing method, make sure you sketch the correct graph. As fx equal to 3x minus 4 is linear, you should get a line. As fx is defined for all x values and all y values, the domain and range of fx are both equal to negative infinity to positive infinity. By using the algebraic method, you need to check the values of x for the domain and the values of y for the range. Based on the given equation, you will notice that fx is defined for all x values. Therefore, the domain of fx is equal to negative infinity to positive infinity. Next, to find the range, you need to find x with respect to y. By taking y equal to fx and simplify, you will obtain x equal to y plus 4 over 3. Based on this equation, x is defined for all y values. Therefore, the range of fx is also equal to negative infinity to positive infinity. For b, fx is a quadratic function, so the graph should be a small curve that started from the point y equal to 1. As fx is defined for all x values, the domain of fx is equal to negative infinity to positive infinity. As fx is only defined for y positive with the minimum point at y equal to 1, the range of fx is 1 to positive infinity. Alternatively, based on the given equation, as fx is defined for all x values, the domain of fx is equal to negative infinity to positive infinity. Next, by taking y equal to fx and simplify the equation, you will obtain x equal to square root of y minus 1. Based on this equation, x is defined for y greater or equal to 1. Therefore, the range of fx is equal to 1 to positive infinity. Let's find c and d using graphing method. For c, based on the graph, the domain and the range of fx, which refers to a quadratic function, are equal to negative infinity to positive infinity and negative infinity to 4 respectively. As for d, the domain and the range of fx which refers to a cubic function, are both equal to negative infinity to positive infinity. Following is the summary of answers for example 2. Now refer to example 3. You need to find domain and range for the following radical functions. For A, based on the graph, fx is defined for all positive x values that started from 2 and all positive y values that started from 0. Thus, the domain and the range of fx are equal to 2 to positive infinity and 0 to positive infinity respectively. As for B, fx is defined for x less or equal to 3 and fx is defined for all positive y values that started from 0. Therefore, the domain and the range of fx are equal to negative infinity to 3 and 0 to positive infinity respectively.